Hi everyone, today let's solve the problem union of doubly linked list. So previously we are done with this one, what do we call solving problem on the binary search. Basically let's solve some problems on the linked list now, right? So here we'll be solving the question union of doubly linked lists. Basically it was asked in ICPC Southern Sub-Regional Contest qualification stage, right? So here what the question states, you can just go through the question is very easy to understand, right? So you can just spend some time on the question, you'll understand the question clear, right? So I'll just summarize the question so that it will be easier for us to solve the problem, right? So just give me a second here, 1 second. So yeah, what the question states here, we are given multiple doubly linked list, right? So just remember this one, we have been given multiple doubly linked lists. So this one, Li represents previous and Ri represents the this one, and Ri represents the next node basically, right? This is nothing but the previous node, and this is nothing but the this one, next node, right? So Li represents previous and Ri represents the next pointers, right? Next pointers, sorry, not node, per node. Each list is linear, no cycles here, right? Each list is linear, they have given, means no cycles. So each list is linear and some may be disconnected and some may be disconnected. So each list here is linear, and linear means here we do not find any cycles, and some may be disconnected. So what we have to do then, we must connect all the lists into one doubly linked list. So this is what we need to do. So in the question they have given, we have been given multiple doubly linked lists, and we know that Li is nothing but the previous and Ri is nothing but the current next pointer per node. So each list is linear, means we do not find any this one cycles, and some may be disconnected. So that's what they have given in the question, and we must connect all the lists into single doubly linked list. So we must connect all the lists into one singly doubly linked list, one single doubly linked list, right? Using only tail dot next equals head connections. We have to use only here tail dot next, this one, tail dot next equals head, tail dot next equals head connections. We have to use only this one. Just remember this one, right? So each list is linear, we know, and some may be disconnected as well. So that's what they have given in the question. We must connect all the lists into one single doubly linked list using this one, tail dot next equals head, using tail dot next equals head. So that's what they have strictly mentioned in the questions. So then we have to print the updated previous and next. Previous means Li and next means Ri. So just remember one thing, whenever we will be making use of this one Li and Ri in the code or in the approach, that means I'm speaking of previous and next pointers, previous and next pointer. So just remember this one, right? So whenever we make use of Li and Ri, we are speaking of the previous and next pointers, right? So we have to print Li Ri pairs, nothing but previous next pairs, for each memory cell 1 to n, from each memory cell 1 to n. So this is what the question states. So I'll just read out the question loudly. Um, this one, so just listen to it, right? So we are given multiple doubly linked lists as Li and Ri for previous and next pointers per node. Each list is linear, means we do not find any cycles here, and some may be disconnected as well. So we must connect all the lists into one single doubly linked list using only this one, tail dot next equals head, tail dot next equals head connections, right? So then we have to print the updated previous and next pairs, or Li comma Ri pairs, for each memory cell from 1 to n, each memory cell from 1 to n. So I hope the question part is completely clear. I hope the question part is completely clear. Means here we have the 7 inputs, right? We have the 7 inputs. Basically we have one inputs. Basically it is a linked list, right? So we have to connect each of them. So here it is considered as one input itself. Means we have seven total, 7 nodes basically. This is nothing but 7 nodes, right? So this is 1, 2, 3, 4, 5, 6, and finally this one is 7, right? So here the output that we need to get for this input as 7 nodes is this one. Accordingly, with the question when we solve, we have to get the output this one. There are multiple outputs for this one. There are multiple output. You can print any valid ones. You can print any valid ones, right? By the question itself says that we can have the multiple outputs. We have to go with any one valid output, one valid output, right? So I hope the question part is completely clear. I hope the question part is completely clear. Let's do one thing. Let's quickly discuss the, what do we call, approach followed by the complexities. Let's quickly discuss the approach followed by the complexities, and then let's write the code. Initially, as usual, let's discuss the approach first. So I have considered the example that they have given in the question. They have only given one example that consists of the 7 nodes, right? So we have seen this one already within the input and the output. The same example that I'm considering over here, right? We have the 7 nodes here. One is 4750 00610204 and 10. So this is nothing but 4750. This is nothing but previous, and this is nothing but next. Same goes with all the this one nodes. So this is this one previous, next. P indicates here previous, and N indicates next here, right? For everything, P previous, N next, right? 47 this one 50, sorry, just give me a second. Yeah, 47500061020410. The output that we need to get here is this one, 475605613224 and 10. So let's see the step by step. Let's move on with a step by step explanation, right? Before moving on to this one, so basically the approach that we'll be making use of here is linked list. So quite obviously, right? So basically the approach that we are making use of here will be linked list, because we must connect all the lists into one single doubly linked list, right? Using only tail.next equals head connections. Quite obviously we will be going with a, we have to, or we will be going with a linked list approach itself, right? So just keep this in mind. We'll be going with a linked list approach, right? So let's go step by step. Let's move on further. Let's go with the step-by-step explanation. So here the first step is we have to build the linked nodes from the input. We have to build the linked nodes from the input. So for this one, we will be converting the input to actual linked node objects. Like so, we'll be going in this way. Nodes of I dot previous or iterated value of the nodes dot previous equals L of I. If it is not equal to 0, then nodes of L of I, else will be printing null. Same goes with the right one as well. Same goes with the right or the next pointer. Here L represents previous and R represents next. Here iterated value of the nodes dot next equals R of I is nothing but this one, next. If it is not equal to 0, then we will print the this one, nodes of R of I. Else if it is 0, then we'll print null. So 0 means we are not having anything, right? So that's what I, if the iterated value of the nodes contains previous. Previous is nothing but L. We know this one, right? Previous is nothing but L. Next is nothing but R. Next is nothing but here R. This is nothing but the previous. This is nothing but the next. That's what here. Nodes of I dot previous equals L of I. This is same as this one. L of I, if it is not equal to 0, then we'll print nodes of L of I. Nothing but the previous nodes. Else will print null. Same goes with the next as well. R of I not equal to 0. Node will print nodes of R of I. Else will print null if it is 0, if it is equivalent to 0, right? So this is the first step. Very simple to understand, right? So next let's move on with the second step. Here we have to identify the head nodes. So we have to identify the head nodes with means nodes with the previous 0. Let's come here. Nodes with the this one previous 0. Here in this case node 3 is having the this one previous 0, node 5 is having the previous 0, and node 6 is having the previous 0. 3, 5 and 6, 3, 5 and 6. See here, node 3, 5 and 6. L of 3 is nothing but the this one, what do we call, previous. All the previous values are 0, right? We have already seen that one, right? So here node of L of 3, L of 5, L of 6, all are 0, means head. head is 0 basically. So heads 3, 5, 6, this one we have the three separate linked lists because the value is 0 or the value of the head is 0. Means we can consider previous value, right? Not the next one. Initially we are considering this one head, so this one previous is 0 here, L of 3, L of 5, L of 6. So here I'll just show you the same here, same goes with here, right? So node 2 here, node 3, node 5 and node 6 all starts with 0, nothing but the previous, the value of the previous one, right? Previous pointer basically, not the previous, the value of the previous pointer 0. Right, so we have heads 3, 5, 6, three separate linked list will be formed for this one. So let's move on with the next step. Let's move on with the next step. We have to join all the lists into one. So finally we have to join all the lists into one itself, right? So here what we'll do, we'll now connect the tail of the one list to the head of the next. So we have first in the previous step what we did, we considered all the values of the previous or the head, uh, which is equivalent to 0, which is equivalent to 0. Now we have to join all the lists into one, means we will connect the tail of one list, we will connect tail of one list to the head of the next, we will connect tail of the this one list to the head of the next. So let's choose the order here. So this will be 6, 4, 1, 7, 3, 5, 2. So this will be, let me come here. This will be 6, 4. So basically this one 6, 4. What is the connection here? Yeah, 6, 4, 1, 7, 3, 5, 2. 6, 4. This one 6, 4, 1, 7, 3, 5, 2. How we join? Basically, list 1, 6, 4, 1, 7 from head 6. 6, 4, 1, 7 from head 6. So I'll just show you here. 6, 4, this one. Head 6, right? 6, 4, 1. So here, 7. This one I'm speaking of. Next, 6, 4, 1, 7. So from the this one, head 6. From head 6 basically, right? So this I hope this part is clear. 6417 from head 6, and we have to find the tail of list 1. List 1 is nothing but here this one, list 1 I'm speaking of this one. So I'll just change the color here. This one, list 1 consists of the 7, right? List 1 consists of the 7. So this will be 6417 was from the head 6, and we are going with the tail of list 1, nothing but the node 7. So this one basically node 7, right? So I hope this part is clear. This one I'm speaking of node 7. So here we will connect the node 7 to node 3. We'll connect the node 7 to node 3. Now just look into the input. It will be now tail is node 3. Tail will be node 3. We will connect 3 to 5. We will connect 3 to 5. So the final list that we got here is 6417. We know we got this one from the node 6. And so as we are connecting the tail, uh, this one we are connecting node 7 to node 3, we will be connecting 3 to 5, we will be connecting 3 to 5. So overall it would be 6417 from the node 6 and 3 and 5, and we need to connect 2 as well at the end, we need to connect 2 as well at the end, right? So this is the final list that we got, this is the final list that we got. So we will traverse and record the final, this one will be not, this is nothing but the previous and this is nothing but the next here. So we have to traverse and record the final, previous and the next values, nothing but this one we have to display in the form of LIRI pair, right? So that's what they have given in the question. LIRI pair means previous next pair. So here we got this one 641735 as the final, this one final list, final full list 641735. That's what we considered here. So for that one, previous and next value we need to find. So here will come, just give me a second. So 6 you can clearly see here, previous is 0, and this one what do we call, next is 4. Previous is 0. Just give me a second here. Yeah, previous is 0. Next is 4 basically. Previous is 0. Next is 4 here. So same goes with 4. Previous 6 and next 1. You'll find for 1, 7, 3, 5, 2 in the same way. This one previous 0 next 4, previous 6 this one next 1, previous 4 and next 7, same goes with previous 1 and next 3, 7 5 for the this one 3, for the 5 it is 3 2, and for the 2 it is 5 and 0, right? So we are just traversing and recording the final this one previous and next pairs, or LI pairs, right? So we need to display in the form of LI pairs itself. So the output that we got here is, so the output that we got here is 4 7 4 7 for the node 1, 5 0 for node 2, 7 5 for the node 3, 6 1 for the node 4, 3 2 for the node 5, 0 4 for the node 6, and 1 3 for the node 7. So this is for the node 1, this is for the node 2, this is for the node 3, this is for the node 4, 5, 6, and this is for the node 7, right? I hope this part is completely clear. I hope this part is completely clear. This is nothing but the final output. So the output that we got here is 5 7 for node 1, 5 4 7 5 0 7 5 6 1 3 2 0 4 and 1 3, which is equivalent to the output that they have given for the example 1, 4 7 5 6 0 5 6 1 3 2 2 4 and 1 0. 1 0 is the final one. 1 0, right? So the output that they have given is equivalent to this one, is equivalent to the output that we got. So here the output differs here. 1 0 was the last actually in the output. So this one we got accordingly with the approach, we got 1 3. Some this one numbers are different. So this is one valid list. So we can have the multiple outputs. Basically they have not mentioned in the question that we have to get the output, same output that they have mentioned for the input, right? So we can have the multiple inputs, we can have the multiple multiple outputs basically accordingly with the input. For the particular input that they have mentioned, we can have the multiple outputs, right? Just give me a second here. Yeah, we can just this is one valid ordering of merged this one merged list. This is one valid order valid ordering of merged list, right? Merged list, this is one valid ordering of the merged list that is accepted basically, right? So this one is one valid answer, you can consider this one is one valid answer basically, and you can try it out in different ways as well, you can try it out in different ways as well. So this is one valid answer, right? So finally, this is one valid answer with the LI-RI pair. So you can just get the different output as well, different outputs as well. So basically, it has to be valid. So whatever they have asked in the question, accordingly with the question, you have to go this one display the answer. This is for this particular question is having the this one multiple outputs, and this is one valid answer. So that's what I wanted to tell. So if you go in the different approach and if you are getting the different LI-RI pair, it is fine. It is fine, right? So that's what I wanted to discuss, right? So now we are done with the approach, we are done with the approach, our the whatever the output that we got matches, almost matches this one. It is not as same as it is not equivalent to the output that they have mentioned, but this is one valid answer, we can go in this way as well, right? So now as we are done with the approach part, let's continue with the complexities. Let's continue with the complexity. So what will be the time complexity here? The time complexity would be big of n for the code that we'll be writing in the future. So accordingly with the approach we are speaking of, right? So the time complexity would be big of n here because we'll be making use of the, or we'll be going with the one pass to read input. So we have to read input. So we'll be going with the input output package, right? So we will be making use of the one pass to read input, one pass to build the structure, and one pass to connect and output. So these are the three things, right? One pass to connect one pass to read input, one pass to build structure, one pass to connect and output. Right, input is one thing, out connect and output the second one, and in the middle one will be going with a one pass to build the structure. So total time complexity would be quite obviously big of n. Right, so I hope this part is clear. Next, what would be the space complexity here? Space complexity would be big of n as well, because we'll be making use of the arrays for storing node objects. Quite obviously we have to store the node object somewhere, right? For that one we'll be making use of the arrays, and also we'll be going with the input links and visited status as well. Arrays for storing node objects, input links and the visited status. So overall time space complexity would be big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n, right? So I hope the complexities part is completely clear. I hope the complexities part is completely clear. Now, as we are completely familiar with the complexities part, let's complexities part along with the approach, let's start writing the code. Let's start writing the code. So initially what I'll do, so let me go with java.input-output.start. So we'll be making use of the fast input and fast output, right? So we'll be going with the input output package. So we need the utilities. So I'll just go with import java.util.start. So this is fine. So the next step here is, let's make use of class main. So within this class, let's go with main here. This is fine. So let me delete this one here. Yeah, within this class, what we'll do, let's go with the node class for the doubly linked list. So we have to output in the single doubly linked list, right? The final structure, li pair. So let's go with the node class for doubly linked list. So here I'll just give static class, this will be node. This is fine. Within the node, what I'll give, so we have to store the index of the node, nothing but one based index, right? So we will be going with the one based index, so this will be int index. So the next part here will be, so let's go with the pointers to previous and next node. Means here in this case, node previous comma next. So this is fine. So the next step, I'll just go with node of int index. So this is fine. Within this one, let's go with the initialization part, nothing but, so let me initialize index to index. So this is fine, I think. So let me come out of this one entirely. So here, mm, so did I miss anything here? So yeah, this one, why did I give here? Just give me a second. So let me cut this one and let me paste it over here. Let me cut this one and let me paste it over here. So this is fine, I think. So here, what shall I do? First, we'll be making use of the fast input reader and fast output reader. So here, this is related to input output buffered reader. So this one I'll just consider br new buffered reader new input stream reader of, so let's make use of the system.in here. We'll be making use of the system.out for the print writer. So I'll just go with the print writer. So this one, let me give output. So new print writer. This one will be new buffered reader new. So this one will be new output stream writer, right? Output stream writer of, let me make use of the system dot out here. So this is fine. I hope this is clear. So this is just the we are just making use of the buffered reader as fast input reader and print writer as fast output writer. So I hope this part is clear. Next part is, we have to read the number of memory cells, nothing but we have to read number of nodes, right? So for that one, I'll just initialize n2 or assign n2 here integer dot percent here of buffer data nothing but br dot read line. So the next step is we are going with the or we will be going with the array of node references. Here in the question they have given one based, so let's go with the n plus 1 here. So I can articulate in the form of code in this way: nodes variable nodes equals new node of this one will be n plus 1. The next step is L of I nothing but the previous, right? So we have to input the previous cell and as well as the next cell for I. So let's do it in the two steps here. Let's input the previous cell for I first, and let's go with the input. Let's input the next cell for next cell for I. First, let's input the previous cell for I. So I can just write it in this way int. So this will be represented in the array, right? So this will be L equals new int of n plus 1, and let me copy the same thing and make the necessary changes for the next pointer, right? So here this will be instead of L this will be R. That's it. Everything remains same. This is fine. We have successfully input previous and next cell for the I. So after inputting previous and next cell for the I, we have to mark if the node has the previous pointer or not. For that one, let's go with the boolean value here. This will be has previous equals new. This one will be boolean, right? Boolean and n plus 1 as it is 1 indexed. N plus 1 as it is 1 indexed. So this part is done. This part is done. So next we have to create the node objects for all the cells. We have to create the node objects for all the cells. You would have already guessed that we will be going with the iteration. For all the cells we are creating the this one, right? Node object. So this will be for int I equals 1, I less than or equal to n, and let's increment the I. So within the for loop, so iterated value of the nodes, let's assign this one to the new node of I. So I hope this part is clear. Right, we are done with this. We have successfully created the node objects for all the cells. After creating the node objects for all the cells, as per the approach, we have to read the connections and build the initial doubly linked list structure. So before LIRI pair, we read the connections and built the initial doubly linked list structure, right? If you remember, 6417 from the node 6, right? So then from the node 7 we considered this one, I think 2, then we got 3 5, right? So finally we joined everything. So first we need to get the 6417 from the node 6, right? So we have to read the connections and build the initially doubly linked list structure first. Let's do it. So here in this case this will be for loop. Let's make use of the for loop here. This will be I equals 1, I less than or equal to n, and let's increment the I. Within the for loop, this will be string parts equals. So this will be buffer data dot read line. Let's make use of split here in this case. Let's make use of split here in this case. So here let's go with the previous cell of I and the next cell of I. For the previous cell of I, nothing but the L of I here. This one will be integer dot percent of parts of 0. Parts of 0 means left side. Left side means first we considered the head with the 0, the head with the value 0, right? First we considered, if you remember the approach, first we considered the this one, what do we call, head 0, right? The value of the head 0. So this will be parts of 0. So nothing but the previous cells of I here, and also we need to consider next cells of I as well. So for that one, let me copy this one again. Let me give the same here, make the necessary changes. This one will be R of I. So this remains same. This remains same. This is fine. So let's continue. Let's continue here. or let's move on further. Here we have to link the previous and we have to mark that I as previous, right? So we have to link previous and next, and we have to mark that I as previous, and we have to mark R of I has the previous, has not as, right? So this one, basically first let's link previous, then let's link next. So let's write the simple if condition here. If L of I is not equal to 0, we have seen this one in the approachment. L of I not equal to 0 and R of I not equal to 0. Two steps. We saw that one, right? So the same thing we are articulating in the form of code. Here means we are linking the previous and next in simple condition, in simple terms. In this condition, within this condition, we are linking previous. So if L of I not equal to 0, then nodes of I dot previous here equals nodes of L of I, nodes of L of I. So this one has to be, so this one has to be within the array, right? We should not be making use of parentheses here. This is fine. So the next step is, after linking the previous, we have to mark that I or L of I has the previous, right? So this one I'll just go with has previous. So where did I give has previous here before? So somewhere we have given has previous. So let me make this one capital P. So yeah, here as well, has previous of I. This one, let's set this one to the boolean value true. Let's set this one to the boolean value true. Let me do one thing. Let me copy this one entirely, and let's do the same thing for the right pointer as well. Means we have to link the next, and we have to mark that R of I has the previous. So this one, instead of L of I, if R of I is not equal to 0, nodes of I dot, instead of previous we have to go with the next here. Nodes of I dot next equals nodes of R of I, and has previous of, instead of I, we have to go with the R of I. And yeah, we are setting this one to the boolean value true, right? We have successfully linked the previous cell of I as previous, and this one next pointers, right? So we are done with this one. So next step, let's move on with the further steps here. So next step is, we have to store the heads of all the lists, means nodes with no previous value at all. We have to store heads of all the list, means nodes with no previous at all. And also, if no pointers are found, then we will consider that one as head itself, right? If no previous, sorry, not pointers, if no previous, then head, we have to consider its head, right? So first let's store heads of all the lists, means here in this case it will be node list of node. Let me consider heads here equals new array list, new array list. So we'll be making use of the array list here. So if no previous is found, then we have to consider its head. So for this one, for int I equals 0, so we have to start from 1, right? 1 indexed. I less than or equal to n I plus plus. So within the for loop, if not of has previous of I, then what we'll do, let's go with heads dot add of nodes of I. So this is fine. So let me come out of this one entirely. Let me come out of this one entirely. So what we'll do now, let's merge all the lists into one. We have to merge all the lists into one, right? Nothing but we are merging the tail of the current to the head of the next. So we have to go with the iteration. So we have to merge all the lists into one, right? So to consider that one, we have to go with the traversal or the iteration. So here for int I equals 0, I less than heads dot size minus 1. So let me go with I plus plus. So within the for loop, so I'll just consider we are merging the tail of the current, right? So let's consider tail here. Tail equals heads dot get of I. We are considering this one a tail here. We are merging the tail of the current to the head of the next. So let me go with the while loop here. This one will be tail dot next not equal to null. Tail dot next not equal to null. So within this while loop, let's go to the end of the list. Nothing but let's assign the tail to tail dot next. Tail dot next. So this is fine. Let me come out of this one entirely. First thing is let's get the next head. So we have to merge the tail to the head of the next, right? First we have to get the next head for that. So again, let me go with node. This one will be next head. Let's assign this one to heads dot get of I plus 1. I hope this part is clear. Then next step is let's connect the tail to the next list's head. That's what we need to do, right? So this one will be tail dot next. So we are making use of the properties of the linked list here. Tail dot next equals. So let's go with the next head. This is fine. So the final step within this one, within merging all the lists into one, yeah, within this step is basically we have to set the reverse link. We have to set the reverse link means we have to go with the next head dot previous equals tail. This is confusing, man. Linked list is always confusing. So just this is fine. So much ambiguity here. So this is fine. So next step after doing this, we have to store the final left links as well as the right links. We have to store the left and right links, right? So means final left and right links. For that one, let me go with this is fine. So this is nothing but final left here. This will be new int of n plus 1 as it is 1 index. This is fine. So let me copy the same thing and make the necessary changes. So here, so we are storing the final left links here, line number 62. In the line number 63, we are storing the final right links. So this one will be instead of left, this will be R. This remains same, new int of n plus 1. This is fine. So let's move on with the further steps here. So next we have to start from the new head. We have to start from the new head. So I'll just go with current equals heads dot get of 0. Heads dot get of 0. So this one, let's write the simple while loop or the while condition here. While current not equal to null. While current not equal to null, then what we'll do, we have to update the left and right. We have to update the left and right. Also we have to move to the next node. After updating the left or the right, we have to move to the next node as well. Let's write those three lines of code. For updating the left, we have already discussed this one. Wrote in a different way. Generally in the approach we wrote this one generally basically, right? So this one will be final L of current dot index we considered, right? Current dot index equals current dot previous. If it is not equal to, if it is not equal to null, then what we have to display, current dot previous dot, this one will be index. Else we have to display 0. Nothing but we are updating the left here. Same, let's we have to update the left or right, right? So here in this case, let's go with right value as well. So here this one will be final R instead of the final L. This will be current dot index. This is fine. This one will be instead of the previous. This will be next, right? So if it is not equal to null, then this will be current dot instead of previous. This will be next again. Next dot index. Else we have to display 0. This is fine. We are done with this one. After the updation, we have to move to the next node. Means let me assign the current to current dot next here. So I hope this part is clear. Let's come out of this one entirely. We are done with the final, we are left with the final part, nothing but we have to print the final output. We have to print the final output. So let's do one thing here. Let's go with a simple for loop for int I equals 1, I less than or equal to n, I plus plus. So this is fine. So within this one, we have to print the final output, right? So let me make use of out dot println because we have to print an individual lines, different lines, distinct lines basically. So this one will be final final L of I plus this one, this is fine. And also we have to concatenate final R of I. We have to concatenate final R of I. So this part is fine. This part is fine. So final step is we are done with input output everything. We just have to flush the output stream. We just have to flush the output stream. So let me come here. So let me give output dot flush. So this is related to the we are closing the this one output stream. We have to just flush the output stream here. Out dot flush. So I hope this part is clear, man. I hope this part is clear. So this is it for the code. So whatever we discussed in the approach, exact same thing we uh, this one what we articulated in the form of code, right? So we articulated the exact same thing that we discussed in the approach in the form of code here, right? I hope this part is completely clear, right? So I hope the code works. Let's see. Let's get the input from here. So the let's see whether this works or not. So let me run this one. I hope I don't get any error. What is the error here? No suitable constructor found for buffered reader output stream rate. Buffered reader output stream rate. So this one is, so this one has to be buffered writer, right? So print writer we are going with. So this one has to be writer, not reader. So this is fine. Let's run this one again. So we still have the error. Line number 18 and 29. 18 what? Unreported exception. Oh, this is throwing this one. Let's add the this one. Throws input output exception. So now this has to work. Let's see. So yeah, we are getting 0 0 for all the outputs. So let's check what is wrong. What we have done wrong. So in the line number 31, we are this one. We are going with the previous cell of I here in the line number 30, and in the line number 31 we are going with the next cell of I. So this has to be next cell of I means parts of 1, not the parts of 0 basically. So now let me run this one. So yeah, now we are getting the output this one. What do we call? 47560561 3224 as well as 10, right? So just give me a second here. So this should work as well. So here we have set this one is fine final n plus 1 1 indexed. I hope this should work as well basically. We have to get 04 and 13. So this should work as well. So we went with here and plus 1. This is fine. Let's see whether this works or not. This has to work accordingly with the approach. I hope this works. If it doesn't work, we have to change somewhere. Let's see. This has to work. Let's see first. So let me do one thing before copying this one. Let me paste the this one signature starter template here. So let me copy this entire code here. Let me come here. This is A, right? Problem A. Yeah, this is fine. Let me paste this one over here and let me hit the submit button. I hope this works, man. Let's see. I hope this works. Let's see. So I can clearly see here running on test one. Let's wait for some time. So yeah, running on test 8. This is running. Let's wait for some time. So yeah, here you can clearly see, right? The code got accepted. The code got accepted means the code works absolutely correct, right? So we don't have to change anything. So I thought it might not work. This is fine. Yep. The code works absolutely right, right? The code works absolutely right for the this one. I mean, yeah, the code works absolutely right. I hope the solution part is completely clear. I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.